New observations of the most volcanic world in our solar system solve a mystery that began with Voyager 1. Flybys of Jupiter's fiery moon Io, carried out by NASA's Juno spacecraft, are helping to solve the enduring mystery of why the small moon is the most volcanically active body in our solar system. Similar in size to Earth's moon, Io has an estimated 400 volcanoes that continuously release plumes and lava that coat that moon's surface. The Juno mission, which has been orbiting and observing Jupiter and its moons since July 2016, made incredibly close flybys of Io in December 2023 and February. The spacecraft zipped within 930 miles, 1,500 kilometers, of the moon's surface, capturing images and data. Together, Juno's flybys have enabled an unprecedented look at the smoldering moon, including taking observations of its poles for the first time. Researchers presented some of the results from an analysis of the flyby data Wednesday at the American Geophysical Union's annual meeting in Washington, D.C. A paper detailing some of the findings was also published Thursday in the journal Nature. Io is one of the most intriguing objects in the whole solar system, said study co-author Scott Bolton, Juno principal investigator and an associate vice president at the Southwest Research Institute in San Antonio. We can see that this body is completely covered with volcanoes over both poles and all across its middle, which are constantly going off. The new data suggests that Io's numerous volcanoes are each likely powered by their own chamber of hot magma, rather than being fed by a global ocean of magma beneath the surface. The latter had long been a prevailing hypothesis by astronomers. The finding could change the way astronomers understand moons dominated by subsurface global oceans in our solar system, such as Jupiter's moon Europa and planets beyond our solar system. Spotting a cosmic pizza. Italian astronomer Galileo Galilei, known as the father of modern astronomy, discovered Io on January 8, 1610. But the moon's wild volcanic activity wasn't detected until Voyager 1 flew by Jupiter and its moons in 1979, revealing Io's dynamic surface that resembled a pepperoni pizza, Bolton said. That year, Linda Morabito, an imaging scientist at NASA's Jet Propulsion Laboratory in Pasadena, California, became the first person to identify a volcanic plume as she studied an image of Io captured by Voyager 1. The revelation sparked a decades-long mystery as astronomers wondered about the origins of Io's constant volcanic activity. Since Morabito's discovery, planetary scientists have wondered how the volcanoes were fed from the lava underneath the surface, Bolton said. Was there a shallow ocean of white-hot magma fueling the volcanoes, or was their source more localized? We knew data from Juno's two very close flybys could give us some insights on how this tortured moon actually worked. Flyby revelations. Io orbits around Jupiter, the largest planet in our solar system, which Bolton calls a monster. The moon's orbit is imperfect, meaning that sometimes it comes closer to Jupiter during its orbit, and other times it is farther away. Io completes one orbit around the planet every 42.5 hours. Jupiter's massive gravitational influence squeezes Io as it orbits the planet, like a hand squeezing a rubber ball, which warms up the moon. This phenomenon is called tidal flexing, or friction from tidal forces that generate internal heat. That's what's happening inside Io, Bolton said. That squeezing is generating heat, and it's getting so hot that Io's insides are literally melting and popping out. The eruptions are constant. It's like a non-stop rainstorm. It's just always erupting all over the place. The constant flexing of Jupiter's tug on Io generates immense energy, which would melt part of the moon's interior, Bolton said. And if the melting was substantial enough, it would create a global magma ocean that Juno could use its instruments to detect. During its close flybys, Juno captured high-precision Doppler data, which measured Io's gravity by tracking how zipping closely to the moon affected the spacecraft's acceleration. The data was compared with observations from previous missions that have flown by Jupiter and its moons, such as NASA's Galileo spacecraft, as well as ground-based telescopes. Together, the observations point to a rigid, mostly solid interior beneath Io's surface, rather than a global magma ocean, solving a 45-year mystery started by Voyager 1's observations. Instead, the volcanoes are powered by more local sources, and each one has its own pocket of magma beneath it. Juno's discovery that tidal forces do not always create global magma oceans does more than prompt us to rethink what we know about Io's interior, said lead study author Ryan Park, a Juno co-investigator and supervisor of the Solar System Dynamics Group at JPL, in a statement. It has implications for our understanding of other moons, such as Saturn's, Enceladus, and Europa, and even exoplanets and super-Earths. Our new findings provide an opportunity to rethink what we know about planetary formation and evolution. The mission has also helped to capture an array of imagery that showcases Io's primordial fantasy land surface, said Heidi Becker, a planetary scientist at JPL who was not involved in the study. The images are bringing different features on Io into focus like never before, including islands spotted on massive lava lakes, such as one called Loki Patera, which is so large that astronomers compare it more to a lava sea sitting on Io's surface. The Juno spacecraft continues to contribute new insights about Jupiter and its moons, having recently completed a flyby over Jupiter's swirling cloud tops on November 24th. Next, Juno will swing by 2,175 miles, 3,500 kilometers, above Jupiter's center on December 27th, logging 645.7 million miles, 1.04 billion kilometers, since beginning its investigation of Jupiter 8 years ago.